6.5 Conditions for rhombuses, rectangles, and squares. The objective in this lesson is to decide if a parallelogram is a rhombus or a rectangle. This sounds really familiar. If you remember, in 6.4, we said if you have a rhombus or a rectangle, then special things happened. In this lesson, we're going to be doing the converse of those things. So we will say, if special things happen, then we can say that our parallelogram is a rhombus or a rectangle. So these should be pretty easy. We've already done this. Let's look at our first theorem here. It says, if the diagonals of a parallelogram are perpendicular, then which figure do we have? Who do we know that has perpendicular diagonals? That would be a rhombus. So we have to have a parallelogram, right? Definition, both pairs of opposite sides are parallel. And then if our diagonals are perpendicular here, then we can say that we have a rhombus. And what's the definition of rhombus? 4 congruent sides. And congruent sides are always useful. Now, the proof of this, we're back to proofs. Let's look at the proof of this. So we are told that ABCD is a parallelogram, and segment AC is perpendicular to segment BD. So let's make a perpendicular here. Now we want to prove that it's a rhombus, so we need to get all 4 sides congruent. Well, how can we do that? Well, what do we know? We know that in a parallelogram, your diagonals bisect, right? Both of them, diagonals bisect each other. So we can say those pieces are congruent and those pieces are congruent. And we know that if we have perpendicular here, we have perpendicular here, and perpendicular here, everybody's perpendicular. Do you see it? I see congruent triangles by side angle side. Do you see all 4 of them there? And then what are we going to use? We can make this side congruent to this side because these 2 triangles are congruent, and these 2 triangles are congruent, and these 2 triangles are congruent. Everybody's congruent, so we use CPCTC to make our sides congruent, and by definition, we have 4 congruent sides. Parallelogram with 4 congruent sides. That's just definition of a rhombus. So there's our proof of this. Pretty easy proof. Nice little proof there. Let's look at our next theorem. It says if now that's nice, one diagonal of a parallelogram bisects a pair of opposite angles. So we know we have a parallelogram, opposite sides are parallel, and our diagonal here bisects the opposite angles, then we have a rhombus. And for our last theorem, it says if the diagonals of a parallelogram are congruent, who has congruent diagonals? A rectangle has congruent diagonals. So we have a parallelogram, its diagonals are congruent, then we have a rectangle, and we can automatically mark our 4 right angles. Parallelogram with 4 right angles is a rectangle. So let's look at our first problem here. identifying special parallelograms. It says, can you conclude that the parallelogram is a rhombus, rectangle, or square? And justify your answers. Well, let's look at A here. What do you see? Well, I see a diagonal that bisects that angle and bisects that angle. So yes, one diagonal bisects opposite angles. So we have a rhombus. And let's look at what we have here. Well, first thing I see is perpendicular diagonals. So what does that give me? Perpendicular diagonals gives me a rhombus. Is there anything more here? Well, let's look at these. Our diagonals are bisected. That's, just parallelogram. But these diagonals are not only bisected, but they're also congruent. So we have congruent diagonals as well, which is our friend the rectangle. So we have properties of a rhombus and a rectangle. So what's that going to do for us? If you are a rectangle and a rhombus, then you are a square. So that one was kind of nice. Make sure that you always look at everything. And I think it's your turn. So go ahead and pause the video and do problem number 1 there. How'd you do on these problems? All right, part A told us that a parallelogram has angle measures of 20, 160, 20, and 160. Can we conclude that it's a rhombus, rectangle, or square? So I drew a parallelogram and I put in my angles, and it doesn't tell us where the angles are, but we know that the opposite angles of a parallelogram have to be congruent. So I knew where to put them. And now I'm looking to see if it has any special properties. Well, how do we know if it's a rectangle or a square? We have to have right angles. There's no right angles, so it's not a rectangle or a square. And how do we know if it's a rhombus? Well, our diagonals are perpendicular, or we have 4 congruent sides. So we don't have any information on the sides, and we don't have any information on the diagonals. So we cannot say it's a rhombus. It might be a rhombus, but we don't know. We cannot say that. So no on the first one. On the second one, it says, suppose the diagonals of a quadrilateral bisect each other. Can you conclude it's a rhombus, rectangle, or square? So I just drew a quadrilateral, drew my diagonals, I made them bisect each other, and I automatically think congruent triangles. And so we've got vertical angles here that it will give us some congruent triangles, but it's not enough. So we have no right angles. At least we don't know of any right angles, so it's not a rectangle or a square. And our diagonals are not perpendicular. At least we don't know they are. We're not told they are, so we can't assume that. So it's not a rhombus. Now, the best we can do on this, we can say that it is a parallelogram because the diagonals bisect each other. But that is the best that we can do. So neither of these were special parallelograms. So the best we could say on the second one is a parallelogram, and on the first one we were already told that. All right, hope you got those. You really have to look at these, draw your pictures, label everything, and look for all of the properties that we have. What's our next example here? Using our properties. So to me, this says algebra. So for what value of x is parallelogram ABCD a rhombus? Well, we know we have a parallelogram, and what special properties does a rhombus have? Well, we know that in a rhombus, the diagonal bisects the opposite angles. So that tells us that those two angles are congruent. And then simply by definition of congruence, we can say that the measures are equal. So we substitute in our values and solve for x. There's our value of x. And guess what? You get to do a problem now. So pause the video and do the next problem. In this problem, we wanted to know for what value of y is parallelogram DEFG a rectangle? Well, we know that in a parallelogram, diagonals bisect. And in a rectangle, diagonals are congruent. So we can mark all of these congruent. And I just made a little point there where they intersect and called it A, because that lets me say that segment EA is congruent to segment FA, which means by definition of congruence, length EA equals length FA. And then I just substitute in, do my algebra, and find that y equals 4. So that was a nice, easy little problem. All you have to do is remember all of your properties. Now, let's look at our last problem here. Using the properties of parallelograms, we are told that builders use properties of diagonals to square up rectangular shapes like building frames and playing field boundaries. So we are supposed that you are on the volunteer building team. You are helping to lay out a rectangular patio at a youth center. So we want a rectangle. How can you use the properties of diagonals to locate the four corners? Well, we know that our diagonals are going to bisect each other to have a parallelogram. And then if our diagonals are congruent, then we have a rectangle. So we make them bisect to get a parallelogram, and then we're going to make them congruent to get a rectangle. So the first thing that we do is we cut 2 pieces of rope that will be the diagonals, and we make them congruent. We cut them the same length. So we take our 2 pieces of rope and we make sure they're the same length, because that is going to give us a rectangle. Right? Our diagonals are congruent. And then if we join the pieces of rope at the midpoints, then they will bisect each other, which will give us a parallelogram. And then if we make the rope straight, the ends of the rope will be at the corners of the rectangle. So isn't that pretty neat? All right, pause the video and do the last problem. This was a fun problem. It says, can you adapt this method to stake off a square play area? Well, how do we know something is a square? Well, it's a rectangle with perpendicular diagonals, right? Because that's the part that comes from being a rhombus, getting the 4 congruent sides. So if we have our diagonals that are congruent, gives us a rectangle. We join them at the midpoints to get a parallelogram, and then we make sure that our ropes are perpendicular to each other, and we will have a square. So this is a nice lesson. It is simply the converses of the properties that we learned in 6.4 about rhombuses, rectangles, and squares. And I think you will have a lot of fun doing these problems. So enjoy your homework.